Okay, it's Mr. Bletcher here with another example of simultaneous equations where we've got a line and a circle. This time we've got an extra step involved in the problem. We've got to rearrange one of the equations before we can do much. So as before, what we're going to have to do is just have a think about labelling the equations. So we'll label the first one number 1, the second one number 2. Now equation number 1 is the equation of a line, but it's not quite in the y is equal to mx plus c flavour, nor necessarily does it have to be for our purposes. What we really need is either the y on its own or the x on its own. Doesn't matter which, you can choose. So I think for this one, what we're going to do is we're going to just get x equal to something, because that looks to be the simplest. So if I take 5 away from that side, and if I take 5 away from that side, that is going to give me 3y take away 5 is equal to x. And I'm going to label that one equation 3. Okay, so that's what we're going to be using to substitute into the circle equation. So that's number 2, so that's circle. Now before we kick off with the hardcore algebra, I just want to give you a little sketch so you can see where we're going with this. So we need the axes of a graph. Equation 2 is the equation of a circle. Now we know this because any equation where I've got x squared plus y squared is a number, it's always going to be the equation of a circle. So let's draw my circle centered around the origin. And here we've got, it's not a y is mx plus c format equation now, it's, x is, my plus c flavour, but the idea is the same. It's just not really going to directly give us the gradient and intercept as we're normally used to getting. You could rearrange it to get that. Now, where it gets to is that you end up with the line coming through somewhere like that. And the 2 coordinate solutions we need are here. Okay, it's not critical exactly how that works, so you could go away and figure it out if you like. We'll learn more about this when we do trigonometry after Christmas. What we really just need to understand is the context. I've got a circle equation, a line equation, and where the 2 cross, they are simultaneous, and we get an x coordinate and y coordinate, but 2 of them, so 2 coordinates, because the line crosses the circle twice. So what we're going to do now is we are going to substitute equation 3 into equation 2. Okay, so rather than for 2 simultaneous equations where they're both lines, where we can get rid of one of the letters by subtracting or adding the equations, potentially we've got to multiply one or both of the equations by a number first, but we can subtract them or add to line equations to get rid of a letter. Here what we're going to do is we're going to substitute our line equation into the circle equation. So over here I've got an equation where I know what x is, so I'm going to substitute that into x. So we've got x squared here, so I've got 3y take away 5, that's my x, but of course x is squared, and I've got add y squared, and it's equal to 5. So far so good. Now I've got a double bracket here, be it it's a single bracket that's squared, but I could write that out long and it would be a double bracket. And now we need to expand the double bracket. Okay, So when we expand double brackets, we always do that with the boxes. So I'll draw my boxes. And we've got 3y take away 5 and 3y take away 5. 3y times 3y is 9y squared. 3y times minus 5 is minus 15y. 3y times minus 5 is minus 15y. Minus 5 times minus 5 is plus 25. We're going to need to collect like terms and simplify, so I'll just draw a little bracket there, a little sort of splodge around my like terms so we can collect them. So we're going to need to simplify. Here we go, simplify. So I've got 9y squareds. I've got minus 30 y's in total. And I've got plus 25. Okay. Now don't forget that's only part of the problem. We're going to have to rebuild the equation now. Rebuild the equation. So remember what we ended up with. Let's go back to the beginning. So we've got the double bracket which we expanded. So I've got 9y squared take 30y add 25. But I also had a plus y squared. And I know that equaled 5. So now we need to simplify all of that and set to 0. So 9y squared add a y, that's going to give me 10y squared. I've got minus 30y. I've got plus 25 and it equals 5. If I subtract the 5 from both sides, then I've got 10y squared take 30y plus 20 is 0. Okay, so now we've got a quadratic equation and we're going to need to factorize it. So we are going to need to know how to bring these together because the coefficient, the number in front of the y squared, is more than 1. So 10 times 2 is 200. So I need a factor pair that adds to minus 30 and multiplies to 200. Okay. So normally at this point I'd be saying do your factor bug for 200 and figure out what your factor pair options are and then move on from there. But that's going to take a little bit of time. Is there just a quick and easy solution we can get? What's going to multiply to 200? How about 10 and 20? So 10 times 20 gives me 200, no problem. Does it add to minus 30? No. So we're going to make both of these negative. Does it add to minus 30 now? Yes. Minus 10, so negative 10 times negative 20. A negative times a negative gives me a positive. That's going to give me positive 200. So we've got our factor pair, we are good. Now we're going to need to do the shimmy factorizing. Let's move that up a bit and then fall off the paper. So where do we start from? So we've got 10y squareds, 10y squareds. So what we're doing here is we're factorising using the shimmy method, which is factorising by partition, which means splitting up our minus 30y into a minus 10 lot and a minus 20 lot. So let's do that. So I've got minus 10 lots of y, minus 20 lots of y. I've still got my plus 20, and it still equals 0. And we need our shimmy thing. Now we need to factorise the left-hand side of that. So that's a number out, letter out problem. So we can take 10 out and a y out. So that's going to leave a y inside there and minus 1 there. So 10y times y is y squared, good. 10y times minus 1 is minus 10y, that all works out. So we've done that correctly. So we know that is going to come across to the other side. Y take 1. We know it's going to equal 0, so the question is what goes in the gap. Something times y gives me minus 20 y, so that must be minus 20. So minus 20 times minus 20, all good. Minus 20 times minus 1, that's going to give me positive 20. That's going to work. Excellent. So we just need to bring that together now. So I know I've got 10y minus 20 lots of y minus 1 equals 0. Now we're at the point where we need to solve the equation. So I know I need either or both of the brackets to be 0. So let's have a look. If y is equal to 1, then 1 take away 1 would give me 0. Okay, that's clearly one of the solutions. And here I know that 10y take 20 is going to equal 0. So I would add the 20 to both sides, divide through by the 10. That's going to give me y is equal to 2. So now I have got the y part of the solution. Let's just remind ourselves where we're going. I know I need two solutions, both of which are coordinates. I've got both the y bits, now I need both the x bits. So, and we're going to do this in kind of two batches so we don't get confused and mix and match our x-y pairing. So we're going to do this by substituting. Now we always substitute into the line equation. Okay, so I know how if I've got y, which I do, I know how I'm going to get my x. So that's the equation I'm going to substitute into, which is equation 3. So substitute line 3. So 3 times y, which is 2, take away 5, and that was how I was going to get x. On this side, 3 times y, which in this case is 1, take away 5, it's going to give me my x. So without straining our brains too much at this point, that's 6 take away 5, x is 1, and that's 3 take away 5, which is going to equal minus 2, so x is minus 2, x is 1. And now we are pretty much there. So again, let's make sure we don't fall off the bottom of the paper. Coordinates. So what are our coordinates for the solutions? We're going to have one here, one here. Just remind ourselves what we're doing with coordinates is an x and a y that go like that. And the x part of that one is 1, and the y bit that goes with it is 2. And over here the x bit is minus 2 and the y bit is 1. And that is how you solve simultaneous equations where one is a circle, one is a line, and we've got to do a little bit of rearranging for the line equation before we start.